Let's say we have an ALU with 2 inputs and 2 outputs, and we want to figure out how many possible functions we can use to map any 2 inputs to any 2 outputs. So we have an input space of 2 to the 2, because it can either be 0, 0, 0, 1, 1, 0, or 1, 1, which is 4 combinations. And then we have an output space of 2 to the 2. And the answer for how many possible combinations is going to be 2 to the 2 for this one times, but in the exponent, 2 to the 2, which will be 2 to the it'll equal 2 to the 8. Now that's actually a pretty big number. It's 256. That means for 2 input and 2 output universal arithmetic logic unit device, you would need a number of control pins that can configure 256 different combinations. And so what you would do is you would be like, well, to do 256 combinations, I'll need 8 lines. So the answer to this question is to make a universal arithmetic logic unit with only 2 inputs and 2 outputs, you would need 8 control lines. So I'll call this the 2 input ALU, 2 output. Now let's generalize this. Say we have an arbitrary base. Let's say it's not base 2, it could be any base. We'll just call it base A. And we'll call this arbitrary base, you know what, we're not gonna call it A. We're gonna call this one C, because it'll look better in the formula. And then we're gonna call this base right here A. So A is equal to base 2, C is equal to base 2. But if we want to generalize it, we could just say this is C. And let's call this right here D. This is the number of inputs. So this is D. And then we'll call this B, the number of outputs. And so our formula turns into A to the B, C to the D. And this is the most general formula for the number of possible states our universal arithmetic logic unit can be in, with a base, with an output base of A, a number of outputs of B, an input base of C, and a number of inputs of D. And this number gets huge really fast. And this is why ALUs don't map every possible function. We pick certain operations like add, subtract, and we multiplex them because having it select from every possible state that we could map our inputs to outputs would be insane. I just want you to plug in, say we're gonna keep it base 2, but say we were gonna do, instead of 2 inputs, 2 outputs, 3 inputs, 3 outputs. This would be 8, 2 to the 24. We would need 24 control pins. Now let's do 4. We do 2 to the 4 times 2 to the 4. That would be 16 times 4. That would be 2 to the 84, which is an insane number. I'm actually pretty sure this is more than the number of particles in the universe. I could be wrong, but it's pretty damn close. This is a massive number of operations. Now, it's only 84 pins, but this is only mapping 4 inputs to 4 outputs. You can see that the entropy increases, not exponentially, but double exponentially, because it does every possible operation. This universal arithmetic logic unit can do every possible operation. And it's pretty cool, but also shows why it's not really feasible to even try to build and why ALUs aren't universal and they're very specifically chosen. Anyway.